Hello everyone. Welcome back to continue the learning. In the previous two sections, we talked about collecting and pre-processing the vending machine data. In this section, we will start to build the predictive model for sales forecast, train the model, evaluate the model, and finally apply it in practice. After learning this video tutorial, you can learn how to build a neural network model, how to train the model, and how to evaluate and use the model. First, let's look at how to build a predictive model to forecast the sales of goods in a region. We use feedforward neural network, which is the simplest neural network and one of the most widely used and rapidly developed artificial neural networks. As shown in the preceding figure, the input node does not provide the computing function and is used only to input data. The two layers in the middle are hidden layers. And nodes at each hidden layer represent neurons that have a computing function. Each neuron is connected only to neurons at a previous layer, receives output from the previous layer, and outputs the output to a next layer. Neurons at the same layer are not connected to each other. The information is transmitted in one direction, and the output results are transmitted to the output layer from left to right. This is a feedforward neural network with two hidden layers. Let's look at the simplest single-layer perceptron of a neural network. The single-layer perceptron has only one hidden layer, as shown in the figure. The first layer is the input layer, which indicates that the input vector is also feature data. After inputting the vector, we import the vector into the activation function. We use the activation function to transform linear expressions into nonlinear expressions. The activation function can be used to simulate data and express complex data distribution. Finally, we determine the result of the activation function. If the result is greater than 0, the result is positive. If the value is equal to or less than 0 in this case, we choose 1. The result is negative. We can implement the task of classification through a simple single-layer perceptron. Let's look at the activation functions used in this model. We use ReLU activation function in this model, which is more complex than the activation function used by the single-layer perceptron. The ReLU activation function is used to check whether the data is greater than or equal to 0. If the data value is greater than or equal to 0, the data value is the value itself. If the data is less than 0, the data value equals to 0. Compared with other activation functions, the ReLU activation function is also a widely used activation function. Well, with the activation function, we'll get the result after we select the model. Let's see how to evaluate a model. We use the loss function to evaluate the performance of this model. Use the gradient descent method to search for parameters in the model. The loss function reflects the gap between the perceptron target output and the actual output. Usually, the mean square error (MSE) is used to obtain the loss function. We hope that the smaller the loss function value, the better. It is ideal that the target output is closer to the actual output. In the process of minimizing the loss function, we use the gradient descent method, because the direction of the gradient vector points to the direction in which the function grows fastest. So it's the direction of the negative gradient. That is, the direction in which the function drops the fastest. The idea of the gradient descent method is to enable the loss function to search in a direction of a negative gradient, and continuously search for and update a parameter of the loss function, so as to finally minimize the loss function and obtain an optimal parameter. To search for these parameters more efficiently, we use an optimizer, which is a gradient descent, an improved version of the algorithm. Often, it encapsulates different gradient descents into an object called an optimizer. The optimizer is used to accelerate the convergence speed of the algorithm, avoid or use a local extremum, and reduce the difficulty in setting parameters manually. For example, the common optimizers for learning rate include the common gradient descent algorithm optimizer, momentum optimizer, Next-Derov optimizer, ADAGRAD, and the optimizer used in our model RMSPROP. OK, Let's look at the code and how to build our neural network model. We use the Keras module in the open source framework TensorFlow to build our neural network. To invoke our model more conveniently in the future, we define a function to construct our model. First, we add a hidden layer. In this hidden layer, we use the ReLU activation function and input all column data in our data to the first layer. Then, add the second layer, which is also the hidden layer. The last layer is the output layer. The OMS Sport Optimizer is used in the model, and the loss function is defined as the MSE loss function. Finally, return to our model, which is part of our definition of the model. Next, let's see how to train the model. Before training a model, we define several hyperparameters. These hyperparameters are manually defined models, which cannot be learned during data learning. We define k is equal to 5. This k indicates the k-fold cross-validation. We used the 5-fold cross-validation when we divided the validation levels. Then we defined the number of iterations as 100, and defined a new list to store our MSE values each time. We then simulate the process of cross-validation. That is, use each of the 5 parts of dataset as a validation dataset one by one. The training sets and validation set are separated. We output the network fee function to enable the model to learn data information. Finally, the MSE obtained each time is saved in a new list that we define. After training the data, we get the MSE. Then, how to evaluate the model? The MSE of the model obtained in each iteration is displayed by using the plot function. In this way, the change trend of the MSE can be better observed. To better understand the number of last iterations, you can obtain the MSE changes of the last 20 iterations. The training set result does not indicate the model performance. We use the test set to evaluate the model and output the MSE of the test set. The MSE of the test set is used to represent the performance of the model, which is a part of the evaluation model. Finally, return to our model, which is part of our definition of the model. How do we use the model? Save the trained model using the save function. After the model is saved, you need to use the model to predict the sales volume of goods in the region. We will use the actual data. In this experiment, we will use our test set to simulate the actual data. Therefore, we also save the test set as CSV data by using the toCSV function. Before applying a model in practice, you need to import the required package. One is Pandas, and the other is TensorFlow. We need to read the data we want to predict. Call the saved model by using the load model function in Keras model. Then delete the first column. The predict function is used to predict data. We can also print the prediction results so that we can apply the model. About how to run these codes in ModelArts, you can follow the last video I told you. Now, let's take a look at some questions to consolidate what we have learned in this section. Question 1. When constructing a neural network, we need to construct the input layer, loss function, and activation function optimizer. These need to be constructed by ourselves. Therefore, the answer to this question is ABCD. Question 2. Which of the following dataset is used to evaluate the model? Is it all datasets, or just the training set and the validation set? The answer is D. What is the validation dataset? The validation set searches for the best hyperparameters of the custom parameters, not to evaluate the use of the model. Okay, I'll show you how to build a model, train a model, display the result, test a model, and save the model. Create a Jupyter notebook, write the code of the model, and call the new data and model to use the model. Note that you also need to synchronize with data in OBS. Click Sync OBS. In this video tutorial, we learned how to construct a model, train and evaluate a model, and apply the model in practice. After learning these important steps, We have a better understanding of the neural network algorithm of deep learning and the basic procedure of iProject development. I believe now you can develop your own iProjects. That's all for this video. Thank you for watching.